Imagine this for a second. You've never stopped moving through time. Not once. Not even while sitting completely still. Sounds impossible, right? But according to modern physics, you're already a time traveler. The real mystery is whether you can control the direction. And that question opens a door into one of the strangest possibilities in the universe. What if time isn't flowing at all? What if the past, present, and future already exist, and we're simply moving through them? For centuries, time seemed simple. One direction, one path, no turning back. Then a physicist named Albert Einstein shattered that idea. He revealed something shocking. Time isn't separate from space. They're fused together into a single fabric called spacetime. Suddenly, time wasn't just a clock on a wall. It became a dimension, just like length, width, and height. And this creates a disturbing possibility. If you can move through space, could you someday move through time? But here's the strange part. Physics doesn't completely reject the idea. In fact, the laws of the universe suggest time travel may already be happening. Right now, every second. The catch? It's happening far too slowly for us to notice. And that's where things start getting weird. Because if time can stretch, if it can slow down, then maybe the future isn't as far away as we think. And maybe humanity has already taken its first tiny step toward becoming a species of time travelers. But that's not even the craziest part. What happens next changes everything. Einstein discovered that speed doesn't just affect motion. It affects time itself. The faster you move through space, the slower you move through time. At first, that sounds absurd, until you realize we've actually measured it. Imagine boarding a spaceship capable of reaching 99.9% the speed of light. You travel to a distant world and return home. For you, only a couple of years pass. But on Earth, decades are gone. Your friends are old. Entire generations have changed. Civilizations may have transformed. You didn't freeze time. You simply moved through it differently. This phenomenon is called time dilation. And unlike science fiction, it's real. But here's the twist. Building a machine to do this isn't the hard part. Surviving the journey is. The speed required is almost unimaginable. Humanity's fastest crewed spacecraft isn't even remotely close. The energy demands are staggering. The forces involved could destroy a human body long before reaching those velocities. So does that mean time travel is impossible? Not exactly. Because hidden deep inside Einstein's equations lies something even stranger. A cosmic shortcut. A loophole. A doorway that shouldn't exist. They're called wormholes. Theoretical tunnels connecting distant points in space-time. Step into one entrance. Exit somewhere else entirely. Maybe somewhere else in time. And this is where it gets weird. Because if wormholes are real, then the impossible suddenly becomes a serious scientific question. Not whether we can travel through time, but whether we're prepared for the consequences if we do. And that's when things changed. The biggest problem with time travel isn't technology. It's reality itself. Let's say a wormhole allows you to visit the past. Sounds incredible, until you make one small change. What if you prevent your grandparents from ever meeting? Suddenly your parents are never born, which means you are never born. But if you never existed, who traveled back to change history? This is known as the grandfather paradox, a contradiction so powerful that it threatens the logic of time itself. And that's the shocking twist. The universe may allow travel into the future, but it fiercely resists travel into the past. Many physicists believe time has a preferred direction. Forward. Always forward. Yet evidence suggests future travel already exists. Astronauts aboard the International Space Station experience tiny amounts of time dilation. When they return to Earth, they're technically living slightly ahead of everyone else. Only milliseconds, but still the future. Think about that. Human beings have already traveled through time, just not in the way Hollywood promised. But here's the question nobody can answer. What if wormholes exist somewhere in the universe? What if hidden regions of space-time obey rules we don't yet understand? Could there be places where the past is still accessible? Could entire civilizations be navigating time as easily as we navigate roads? Or would opening that door unleash paradoxes beyond comprehension? One thing is certain. The deeper we investigate time, the less we understand it. Because the greatest mystery isn't whether time travel is possible. It's whether the future already knows we're coming. And if a doorway appeared tomorrow, would you dare step through it?